Oh, right. Hey, Dorothy. So it seems like you're having a little bit of problem with functions and function notation. So functions is what we're going to be talking about. Um, and listen, there's nothing about this that you probably don't know um, from doing just regular kind of algebra. Say I gave you something like this. Y is equal to 4x plus 2. Now, chances are you've seen this. I know you've seen this because we've gone over this. Um, you can't answer this problem, right? There's not one answer for this. There's many answers for this. There's combinations of x and y that make this statement true. And normally what we did was we made ourselves a little table, right? And there's this little table. And we said, if x equals this, then y equals this, right? So we can pick out some numbers, 0, 1, 2, 3, right? And what do we say? X equals 0. So we're going to plug in 0 for x. Well, 4 times 0 is 0, and 0 plus 2 is 2. So 0, 2 is one solution. Okay? I plug in 1. 4 times 1 plus 2. 4 times 1 is 4, plus 2 is 6, right? And you could just keep kind of doing this, right? You can plug in 2, right? So going to be, what's it, 10, right? And there were all these combinations of x and y that made this statement true. All right. Now we call this an equation, even though this is pretty much a function. The most common way you see a function explained is pretty much, hey, there's a box, some magical box, and you're going to put some stuff into the box, right? And then some stuff is going to happen, you're going to get some stuff out of the box, okay? Now, we used to call that the x's that we were putting in, and we used to get y's out. Now we're not going to call them y's anymore. We're going to call them f of x, okay? So we're going to say f of x. So this is just y, okay? Now, we're going to talk about why we have a new notation here, why we don't just call it y all the time in a few minutes. But pretty much, you're going to plug in some x's, some stuff is going to happen inside the box, and some f of x's are going to come out. Just as a note, they don't have to be f of x's. They could be g of x's, h of x's, not I. I'm going to use I, h, I, j, right? J of x, k of x, and all these things, right? So usually we start with f of x, and we would say that this is a function of x. That's why we start with f, okay? And what happens inside the box really depends. It could be, the linear stuff. F of x equals mx plus b. That y equals mx plus b will also be f of x equals mx plus b. It could be something like quadratics, right? Ax squared plus bx plus c. It could be something else. It could be, I don't know, the square root of x. It could be x to the third power. It can be all these different things, absolute value of x. There's all these different things that could go in. Now, you didn't have to call the function before because for things that you've been dealing with, namely linear stuff and quadratic stuff and some of the other stuff, there hasn't been a need to differentiate between an equation and a function. So you just call them a function, you just call them an equation, you call this y. Okay? Right? But because of some of the new things we're going to have to look about, some of the simple rules, and there's really only one rule for functions, we're going to give this a different name, and it's now called h of x this time. Okay, so this is pronounced h of x. So I'm plugging in x's and getting out h of x. You can call it f of x, g of x, h of x. First of all, why using that is a little bit useful. If you remember doing systems of equations, y is equal to 2x minus 4, and then y is equal to 3x minus 7, right? And we would solve for this, right? We would find out, either where they intersected or set them equal to each other, or substitute. We had all these different methods. Well, if we were looking for their intersection, wouldn't it be useful to denote that these are two different things? Well, if we're going to call them functions, then we can give them two different names, right? We can call them, I don't know, something like, usually we start with f of x, lowercase f of x, by the way, and lowercase g of x, never uppercase, until you get to very high level math. But essentially, it gives us a handy way to differentiate between two different things. So they have different names now. They're f of x and g of x. So how the notation differs is something like this. Say we were given an example. We said y, I'm sorry, not y anymore. f of x, right, is equal to 2x plus 1, right? Well, again, we're still going to have that same kind of chart mentality, right, where I'm going to choose x's to go in, but now I'm not going to have y's come out. Now I'm going to have f of x's come out. They're still graphed the same, right? This is still this way, and this is still up and down, okay? So now we're going to choose some different numbers. Let's choose 0, 1, 2, and 3, okay? So what would we say? We would say this function evaluated at 0. Now that's not f times 0. That's just telling you that this function is being evaluated at 0. That's 2 times 0 plus 1. So 2 times 0 is 0, 0 plus 1 is 1. Nothing about the math changed, okay? All that we're really changing right now is the notation. We're saying f of 1, in other words, this function evaluated at 1. So again, it's more useful than y because now y is telling you something. It's now telling you, hey, this is the number I'm putting in. So it's not just saying y is a standalone thing. It's saying here is the function evaluated at this number, okay? So 2 times 1 is 2, plus 1 is going to be 3. So again, we're still going to have these coordinates. So it's going to be 0, 1, it's still going to be 1, 3. Nothing about those things are changing, okay? So again, f evaluated at 2. F of 2 is how we say that. 2 times 2 plus 1, 2 times 2 is 4, plus 1 is 5. So f of 2 is 5. Again, still the same point. Again, f of 3. And again, you could put other numbers in here. Could you put 3.5? Sure. Would you want to? I don't know why you would, but you could, right? Could I put pi and say what's f of pi? Sure. We could evaluate that. 2 times pi plus 1. Okay. Again, hard to graph and everything like that, but there is some answer I get when I plug that number in. Okay. So let's take a look at your two problems that I saw on your paper. Okay. Oh my God, did I actually pick the one? Oh, I did. Awesome. Okay. So, I'm sorry, I didn't do that on purpose. So all this is saying is, here's your function, 2x plus 1. It's what used to be called y is equal to 2x plus 1. And all they're saying is x equals 0, x equals -1, and x equals 2. What does y equal? Okay? In other words, what's the coordinate? Okay? The only thing that's changing is some of the notation we use. Okay? We're not going to say y. Right? We're going to say something like f of x. And we're not going to say y. We're going to say f of 0. So again, now our y value tells us a little bit more. It tells us not only what y is, but also what was plugged in to get that value. Okay? So all you really have to do for these three things is plug in these three different numbers. Okay? We're going to plug in 0, we're going to plug in -1, we're going to plug in 2. Okay? So again, let's take a look. Let's say f of 0. In other words, what's this function evaluated at 0? It's 2 times 0 plus 1. Well, f of 0, therefore, would be, well, 2 times 0 is 0. 0 plus 1 is going to be 1. Let's say what's f of -1? Let's evaluate this function at -1. 2 times -1 is -2, and -2 plus 1 is going to be -1. So we would say f of -1 is equal to -1. Okay? And your last one says, what's f of 2? So f of 2 is equal to this function, 2x plus 1, evaluated at 2. So 2 times 2 is 4, plus 1 is going to be 5. So f of 2 is 5. So again, we now know the coordinates very easy. Well, x was 0, y was 1. F was -1, y was -1. F was 2, f of x was 5. Okay? So again, it's a nice compact way of writing these things, and it should make things a little more clear in the future. Okay? So again, all you really need to do is plug in the numbers and evaluate. Right? Your other example, though, is below that you didn't ask me about, but I'm going to answer just because this explains why we had to change this. Okay? There is one rule when it comes to a function. Okay? And that is in your function machine, right? In your function machine, right? We have inputs and we have outputs, right? Inputs x, your outputs for f of x, okay? You cannot have one input give you two different outputs. That's not okay. It's okay if there's no output, okay? It's okay if you plug in something and nothing comes out. The one thing you cannot have is you cannot have two different things come out of this. You can't have 3 or 4 or 5. Either there's no answer or there's one answer. That is it. You cannot have two different answers, okay? So I'll give you an example for this one. Oops. If I said, what if I said r of negative 5? Well, that would be the square root of, we would plug in negative 5, right? I've already seen an x replaced with a negative 5. And negative 5 plus 1. So r of negative 5 is equal to the square root of negative 4. There is no square root of negative 4. Okay. Well, there is. You just don't know about it yet. Okay? When you go on your calculator, say, hey, what's the square root of negative 4? And your calculator tells you to go scratch, right? So it's a non-real answer. Okay? So is that okay? Yeah, there's no answer. That's fine. That's okay that there's no answer there. Now, that wasn't a problem before, right? That wasn't even an issue when you were talking about things like this, because there's always an answer. There's always an answer for things that are quadratic, for things that are linear. There's always an answer, okay? This is the first time we face something there's not an answer. Now, that's okay that there is no answer. There is another problem, okay? So let's go ahead, let's evaluate these. Now, let's see. Hey, r of 0 means let's plug in 0. 0, oops, 0 plus 1, sorry. So 0 plus 1 is 1, and the square root of 1 is 1. So r of 0 is equal to the square root of 1, which is 1. So we put in 0, 1. But, okay, hey, aren't there two different answers for the square root of 1? Isn't the square root of 1 either 1 or negative 1? Right? Because isn't negative 1 times negative 1 also positive 1? Okay? Now, normally, if there is a question like this, you would want both of those square roots. You remember that from doing probably the quadratic formula and a couple other different things. But here's the thing. Since I told you it's a function, there can only be one answer. So we only want the positive number, right? So if I said this, and I'm going to tell you something that grinds my gears in math a little bit. If I told you this, and I said x is equal to 0, well, now I haven't told you this is a function. I didn't say this was an equation. Up until 2 weeks ago, or whenever you started this unit, that was an equation, and this should have two answers, right? Y could equal positive or negative 1, okay? Now, if I said the function this, then because I told you it's a function, you need to know that there's only one answer, okay? So really, here's the thing. They made a big stink about you making sure you gave the positive and negative answers for square roots, and now they don't want the negative answer, okay? So here's the big deal. If you're a function, you can either have no answer or you can have one answer. So this only gets the positive, or what we call the principal square root. We only want the positive result, okay? So again, your next one, r of 3. All right, so we're plugging in 3. So r of 3 is equal to the square root of 4. And again, we only want the positive square root because it is a function. Since it's a function, we only want one answer. We can only have one answer, okay? And the last one, r of 8, means let's plug in 8. 8 plus 1 is 9. R of 8 is equal to square root of 9, so r of 8 is equal to 3. Okay, and again, we can go ahead and we can say if x equals 8, then y equals 3. Okay, and again, what you'll probably get into, hopefully if you haven't already, is starting to graph some of these things, and really that's what it is. Okay, so I hope this helped. Pretty much your bottom line is this: is that if it's a function, it's the same thing you've been doing with equations, right? So just plug in x's to get out y's. Except now we're saying you're plugging x's to get out f of x's. We're using a little bit fancier notation, but the math itself has not changed. The one thing you have to remember is that you're only allowed to have no answer or one answer, right? So For a problem like this, where there's two different answers, you need to just take one, because I told you it's a function. What they're going to ask you in the future is, hey, is this a function? And give you a graph, and you're going to have to say, yes, it's a function, or no, that's not a function. Okay? So anyway, I hope this helped, and I will talk to you soon. Bye.